All right, so let's plug in -1, 0, 2, and 5 to x plus 2. So if you plug in, you get -1 plus 2, 0 plus 2, 2 plus 2, and 5 plus 2. So that gives 1, 2, 4, and 7. In the next example, we're going to take those same values and plug them in again, but now we're plugging into -2x plus 3. So that's like -2 times -1 plus 3, -2 times 0 plus 3, -2 times 2 plus 3, and -2 times 5 plus 3. So we get 5, 3, -1, and -7. And it should make sense to us that these numbers are decreasing because the slope of the line is negative, so it's going down. So this is an example of a linear function. This is a linear function. If something is raised to the power of 2, that's a quadratic function. And then example number 4, we should know that the absolute values bar, make that an absolute value function. So as we progress through the year, you'll be able to identify each of these functions by their names. So for the quadratic, same idea. It's 2, -1 squared plus 3, 2, 0 squared plus 3, 2, 2 squared plus 3, and 2 times 5 squared plus 3. Let's make the 1 a 3. So we get 5, 3, 11, and 53. If you had done it ahead of me with the 1 that's on your handout, then your answers would have been 3, 1, 9, and 51. That had just been 2 less than my answers because it was +1 versus +3. So you could have just subtracted 2 away. Okay, and last but not least, we have the absolute value. So the absolute value function makes it that it is always a positive. You still plug your answer or value in as the negatives or positive. So absolute value -1 minus 3 equals 4. Absolute value 0 minus 3 equals 3. And absolute value 2 minus 3 is 1. And absolute value 5 minus 3 is 2. So we are going to continue to reiterate some vocab. We had some of these vocab words the other day in that study guide and intervention. What we're going to do today is just reiterate them. A function is a relation in which each element of the domain is paired with exactly one element of the range. Each element of the domain is paired with exactly one element of the range. So in layman terms, for every x, there is only one y. A function says for every x, there is only one y. A function in notation or standard form is read as f of x or a function of x. Pretty much for the remainder of the year, you will see function notation. We will continue to use function notation for a majority of this year. The vertical line test says if a vertical line passes through more than one point on a graph, then that relation graph is not a function. We also have one-to-one and onto. One-to-one says that each element of the domain pairs to exactly one unique element of the range. For every x, there is only one y, and for every y, there is only one x. And onto, it simply says that every element in the range corresponds to an element of the domain. So what it means is you cannot have a y value without an x. And graphs that have every x only going to one y and every y pairing back to an element of the domain is known as both. Right? Is everybody good? Got it all copied down? All right, so domain and range. Determine if each element of the function is a function or not. And then if it is a function, is it one-to-one or onto? So determine whether it is a function and then if it is one-to-one, onto, or both. So in number 8, for every x, there is only one y. So yes, it is a function. And then if you think about one-to-one, each element of the domain pairs to exactly one unique element of the range. So is number 8 one-to-one based on our definition? Would it pass the horizontal line test? No. Because 2 and 3 both map to 6, it is not one-to-one. So it is only onto. What? It can't be both if it's not one-to-one. Yes. Correct. It passes the vertical, it doesn't pass the horizontal. So like if you were to plot those points, let's just say, here, let's erase this one. So like 2 is at 5, 3 is at 6, but 4 is also at 5. So it would pass the vertical, but what it doesn't pass is the horizontal because you have a point at 5 twice. So therefore not 1 to 1. Does that make sense? Okay, number 9. This is not a function because x equals 0 has 2 y values. Not a function because x equals 0 has 2 y values. This would fail the vertical line test. Number 10, also not a function because x equals -3 maps to 4 and 5. So again, fails the vertical line test. And if it's not a function, we don't care about it being 1 to 1 or onto. Okay, 11. Use the vertical line test to determine whether that is a function. If it is a function, is it 1 to 1 or onto? 11 is a function because it passes the vertical line test. It is not 1 to 1 because it fails the horizontal line test. So it is onto. And 12 is not a function because it fails the vertical line test many, 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 many times. So there's not one particular value of x in 12. It fails at a lot of values of x. Okay, let's graph this example. So we have 1/2 x minus 3. So the -3 is your y-intercept. The 1/2 is your slope. So we're going to talk a lot about graphing linear equations in the next few days. If you didn't know how to graph it, you could always plug it into your graphing calculator. Eventually, we're going to get to a point where you cannot use a graphing calculator. So the y-intercept is our starting point. And then from there, we apply our slope of up 1 over 2. The domain of all linear functions is always all reals. The domain of all linear functions is always all reals. The range of all linear functions is also always all reals. So the domain and range of a linear function is always all reals. And linear functions are exactly that. They are functions. They are 1 to 1. They are onto. So really it is a case of both. And linear functions are continuous. So that goes back to our vocab from the other day. Linear functions are continuous. Questions, comments, concerns? Your homework is that next page in the packet. So for 14 to 19, oh wait, just kidding. We have another whole set of problems. Yeah, your notes go onto that next page. Sorry. However, we're just going to incorporate it into your part of your homework because we're going to run low on time because it took us so long to go over and check stuff. So these are pretty easy. It's very much like the warm-up. If you're finding f of -3, it's the same as finding x equals -3, but now we have new notation. So it's 3 times -3 minus 5, or -9 minus 5, which is -14. F of 0 is like 3 times 0 minus 5, or -5. And f of 5 is like 3 times 5 minus 5. So you get 15 minus 5, which is 10. So all you're doing is plugging in 3 different numbers to the same function for their variable. So you're finding the function at those points. So you have 3/4 -3 minus 1, 3/4 0 minus 1, and 3/4 times 5 minus 1. So you get -9/4 minus 1, which is kind of like -9/4 minus 4 over 4. So you get -13/4. And here you'd get 15/4 minus 4 over 4, which is 11/4. So your homework is that 16, 17, and then the next page, which is 2-1 homework day 2, 11 to 13, and then 21 to 32. Tomorrow, I'll pass back the study guide from 2-1, and we'll go over all of this.